Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 14th March 2025, and the problem is maximum candies allocated to K children. So as I always say that we will start with the title and then we will go to the constraint of what constraint are given, then we will read the problem statement and then we will see the example that how it can help us to understand the problem exactly. So the problem says that maximum can be allocated to k children. It means that there will be some candies and it will be allocated to k children. So this is the so from the title statement is only so that there will be some candies and it have and we have to allocate it to the k children. So from this statement, it is not obvious that either it's any specific algorithm will work, but yeah, we can say that from here we can assume that either it could be something like sliding window or two pointer problem, but we are not clarified or specified that this problem could be any specific problem related to a specific pattern. So what the constant are given, so constant are given are 10 raised to the power 5, and here the candies value can be differ from 1 to 10 raised to the power 7. So and keep all value also differ from 1 to 10 raised to the power 12. So from the candies it suggests that okay, we have 10 maximum of 10 raised to the power 5 candies, so our algorithm must follow something like n log n or order of n. Linear time complexity should be there so that all the test cases that are given in this problem will be accepted. So now let's read the problem statement. You are given a zero index integer array candies. Each element in the arrays denote the piles of candies of size candy size. Okay, you should note this is a statement that a piles of candies of size candies. So from this title it says that okay, they might be interested us to distribute it in the piles of candies. So you can also see that these are the candies and these are the piles of candies of type 1, and these are the candies of type 2, and these are the type 3. Okay, so here is the 5. We can, if you we will try to distribute the 5, we can say 1, we will distribute we will say 1 and 4, something like that, or maybe 2 or 3, and 3 or 2 are already been there. So these are the two possibilities that we can divide the 5 into. Either we can also divide it as 5 and 0, 1 4 2 3 3 2 4 1 and 5 0. So these are the three unique distribution that can be possible, that we can divide the current candy of size 5 piles. So these piles will be converted like 1 to 4 or 2 to 3 and 5 to 0. So denotes a piles of candies of size candies of I. In case of this, you can see that 5 are the candies of I. You can divide each piles into any number of sub piles, but you cannot merge. But you cannot merge that. It means that if you have two, if you divided the piles, if you divided the candies into n number of piles, you cannot combine it together to solve your problem. You are also given an integer k. You should allocate piles of candies to k children so that each child gets the same number of candies. So these are the problem statement that you have to allocate the piles of candies to k children. It means that it is asking you that you have to divide the piles of candies into exactly k children, and each children should have same number of candies. Children can be allocate candies from only one pile. This is also a very important statement that you can only allocate piles of candies only from type 1, only from a single, only from a single pile candies. You do not allow to take the piles from the different candies, and some piles of candies may go unused. It means that you can divide. If you've divided 4 and 1, then 1 you can give to first children, and you can go give the 4 to the second children. And then if you do so, let's say I will say 6. Okay, if I will say 6, then 6 will be like something. Okay, like 6 comma 0 or 1 comma 5, 2 comma 4 and 3 comma 3. So this will be the distribution. So you are not allowed to do something like you will give the 4 pies from the first candy and you will give 1 pies from the second candy. You are not allowed to do so. So you just have to give a single candies, piles of candies of only single type. So you have to return the maximum number of candies each children can get. So what the overall problem statement is that, okay, you are given an array of candies, and each candies can divide into n number of piles and can be vary from each piles. I mean, it can be divided into piles, and you have to distribute that into the k children, and each children should have only one type of candies. And also, if you will distribute in the given rule, some of the piles of the candy may go unused. So you have to return the maximum number of candies of each children can get. So how we will approach now? Okay, let's see the example one first, and after the example we will see that how will be our approach to solve the problem. So candies are given 5, 8 and 6, and key values is 3. So from here it is very obvious that, okay, only we have to distribute among the 3 children. So you can also see that, okay, what could be the maximum, the minimum value of these 3 will be the 3, because you have the array of 3 and you have to distribute among the 3 children. So the minimum value of this will be our answer. So 5 and 5 and 5. So let me convert this 8 into 5 into 3 and 6, 5 and so what I will do, I will give this 5 to, let's say, the child like C1, C2 and C3. So these are the 3 children. What I will do is that, okay, because I have to maximize the number of candies to each children, what I will do is that, okay, I will give the 5 candy to the first child, and these 5 to the second child and these 5 in the third child. So there will be the, if I will say that type 0, type 1 and type 2, then type 1 candies have left three piles, and in the similar way the type 2 candies have left the total of 1 piles of candies of type 3, sorry 2. So this is the problem. Okay, if there is the, let's say, case 4, what we I will do. Okay, there are the 4 children now. So to solve the number of children 4, what I will do, okay, you have to divide into 4 childs. So in this case, can we give 2 to, yeah, so let me show you this one. Okay, instead of, what I will do, I will check, okay, can we give 3 plus 2? 3 is already there and it will be 6, so 3 plus 3. So from here you can see that, okay, what will be the total number of 3? 1, 2, 3 to 5. So 1, 2, 3, 4. We can distribute among the 3. So 3 is the correct answer. It can be the possible answer. We can increase also. So let's try to increase it all as well and see that we can be able to, let's see, either we can be able to distribute 4. So to convert it 4, what will I will do, 1 and it will become 5, and now I'm become 4 and 4. Okay, and it will become 4 and 2. So the total number of 4 is there, 1, 2, 3, 4. Okay, so from here 3 could be the answer. Now answer will become 3, and here I see that answer became 4. So let's see if the answer could be the 5. So here is the 5 and 5 and 3 8, and here it will become 5 and 1. So only the 3 5 are there, but the total number of children is 4. So it cannot be possible to distribute 5 piles to each children. So our answer is 4. So if you will see, what I have done here is that is kind of, trying to find out that what could be the answer. I have started from 3. I can also start from 1, then 2, and then 3, and then 4, and 5. So this makes sense of binary search. So here the binary search came into picture, that okay, instead of dividing manually, instead of dividing each time into key children's, what I will do, I will do binary search in answer. So if you are familiar with the binary search in answer, it is very basic problem for the binary search is answer. Binary search in answer. So how, so let's try to see that what could be the minimum and maximum answer. Minimum answer could be, because each of the have one. So in this example you can see that there are the 11 children, so it is not possible because the total number of piles is only 7. If you will distribute minimum of 1 to each, we will only get the 7 children who will get the candies, and there will be 4 children who have not get any candies. So answer could be 0, Answer could be 0 from children can have maximum of the maximum in these array. No, minimum of these three, because each minimum of these elements in the array. So we will solve using the binary search in answer. If you have any query, you can ping me below in the comment box. I will reply you. Let's try to code it now. So first I will do public, because it will and this search it will candies. Okay, and then okay, I will make a variable int count equal to 0, x these. I will check if no, what I will do is that I will distribute how many to how many children I can distribute it. So I will do that. Okay, it is candies count plus equal to x divided by mid. I will return that count is greater than or equal to k. I will show you on error after the solving, then I will fix that what was the issue. So and then equal to candies dot length l equal and r equal max maximum equal to 0. Here for the r, I am using the maximum value in the candies. You can take any a greater value which can be in the range of maximum bond. I mean that you have to take any maximum value of r so that we can do binary search in the answer. In my case, I'm using the maximum element in the given candies array. Okay, so L will start from 1, and why is 1? Why is not 0? Because okay, let me show you that while to make answer, you have to return it. Okay, you have to find out mid and the Candies, and then you must have it. I will do answer equal to mid, and I will reduce the answer. Sorry, increase the answer equal to mid plus 1. As what I have to do is that r equal to mid minus 1. Okay, now if I will convert this to 0, what will happen? Let's see. That's that. What is happening here? It's not so error, I guess. Mm-hmm. Yes. There's something missing, I guess. Oh shit, that was the issue. I was thinking what happened actually. This should be in this method. So you can see that here it is showing that divided by 0. You can also see that mid can be 0 because my answer range is from 0 to max. So in this case I will convert to 1. Now, okay, you can see that these three test cases have been passed, but here it is the wrong answer. Why? Because you can see that value of k is very long, and because it is adding the value, so it should be the long. So I will convert this to long. This was the issue I was talking about before. So I guess done is done now. So you can see that these test cases have been accepted that are given here. Let's try to submit it now. You can see that our code have been submitted and have been accepted as well, and it took 32 millisecond and beats 33.87% of the people who have been submitted in Java. And this is the memory that we have taken, 6310 MB, and it beats 69.89% of the people who have been submitted in Java. So in case of time complexity, as I have so the time complexity for this method is order of n, and because it is the binary set, so it is the log n, so total time complexity is order of n log n. So let's see what could be the time complexity. So you can see that log of maximum candies into n. So n log n is the time complexity. So let me clean the code now so you can see the clean code. Okay. So this is our code. So you can see that this is our code that we have written. So alright guys, if you have any query or suggestion, you can ping me below in the comment box. So alright, if you have any query or suggestion, you can ping me below in the comment box. I will definitely, when I will get the time, I will reply you. And please, and one more thing, happy Holi to everyone who is watching me from India and across the world who celebrate the Holi. So please share my videos to your friends who are interested in CP as well as the DSA, and please be consistent. Thankfully I am able to be consistent in more than 1 month, you can see here. So please share my channel, like my videos, and comment me below. Thank you and happy Holi to everyone once again.